Okay, so this is the foundation paper, question 5. On a farm, a forklift truck is used to stack wooden crates of Welsh apples. Each crate is 0.8 meters tall, and we have here a stack of 2 crates. So each crate of apples has a weight of 450 newtons and is 0.8 meters high. So don't forget that the weight is the action of gravity on the apple's crate mass. Okay. Use an equation from page 2 to calculate the work done in putting crate A on top of the 2 other crates. Okay, so we need to refer to our data page, our calculation page, and we're looking for a calculation that will help us to work out work done, or a formula that will allow us to calculate work done. So if we turn back to here, it does say down here that work is force times distance. W equals FD. Okay, so if we just write that down here, so work is FD. So what we need to do is find a force and a distance. Okay, and in our question we have a value here in newtons, and newtons are the units of force, so we can consider the weight to be a force, and we have a distance. Okay, now we have to be careful here because it says it's putting crate A on top of these 2 crates here. So the bottom of the crate there is going to be raised to the height of the top of these 2 crates here. So obviously that's 1.6 meters altogether because there's 2 0.8s. Okay, so our force is 450 newtons because that's how much force is required to lift this crate against gravity, and we're going to multiply that by 1.6 meters because that's the total height of these 2 crates here, because of course the bottom of that crate is going to end up just on top of there, so the whole thing will be lifted by 1.6 meters. So if we refer to our trusty calculator, we don't make any high pressure errors during our exam. So let's put that in there. So 450 times 1.6 gives us 720 joules of energy. So it requires 720 joules of energy to lift that crate up onto the top there. State the gain in potential energy of the crate when lifted onto the stack. Now, one thing we need to remember here is the principle of the conservation of energy, which states that energy can neither be created nor destroyed. It's just transferred from one form to another. So that work done, that energy, I suppose it's kinetic energy lifting it up to the top there, is transferred directionally into potential energy or gravitational potential energy. So that's also 720. So that crate of apples has 720 joules of energy because it's been lifted up against gravity. Okay. Then it says, give a reason why the forklift truck uses more energy lifting the crate A than the work done calculated in part 1. And this is all to do with energy wastage. Okay, so the forklift wastes energy in the form of heat and sound whilst working. So the energy stored in the fuel of the forklift truck, some of it is converted into heat, which is simply wasted, and also the sound that the forklift truck makes is wasted energy. It doesn't do the job of lifting up that apple crate any good at all. It's just wasted energy. So that's why more energy is required than 720 joules. Okay, and then the final part of this question, each crate of apples has a weight of 450 newtons and the mass of an empty crate is 12 kilograms. Calculate the mass of apples contained in the crate. And it reminds us here, as we've seen in the previous question, on Earth, an object of weight 10 newtons has a mass of 1 kilogram. Okay, so effectively we divide the weight by 10, and that gives us the mass. Okay, and if we do that to the full crate of apples, then we can calculate the mass of a full crate of apples. So 450 newtons divided by 10 kilograms per newton gives us 45 kilograms. So the full crate weighs 45 kilograms. The empty crate weighs 12 kilograms. Okay, so 45 take away 12 gives us a mass of 33 kilograms. Okay, so it's just a case of converting that one into kilograms using the information you're given here.